All right, so looking at our do now for today, we're just going to look over these really quickly. These are review questions from the quiz. We should be able to write equations for these using the Q is equal to percent times whole equation. The number of boys in a school is 120% of, all right, so we have the 120%. This is a percent of problem, it looks like. There's no percent increase or decrease here, right? An equation that could be used to find the number of boys if there are 320 girls. So percent of, remember the of tells us what the whole is, so this is of the number of girls. There are 320 girls, so the whole is 320. Our percent here is 120% because this is not a percent increase or a percent decrease. So this is a multiplication. Q is equal to 120%. Change that to a decimal, 1.2 times 320. And that's as far as I really want you to go. Coming over here, the membership increased from 25 to 35. So this is one where it's increasing, but we notice the question asked me percent of the old membership. So the question actually tells us this is a percent of problem. Q is equal to blank percent times whole. Percent of what? The old membership. And it says the new membership as a percent of the old membership. So the new membership is going to be 30. The old membership is going to be 25. So this one gets a little bit tricky. We might think about this as a percent increase or a percent decrease problem. But it's actually, when we look at the question, it asks us for percent of. So this is definitely a percent of problem. A $400 bike is on sale for 45% off. So this is a discount problem. This is something where something is definitely changing. We can see here the final price is what we're looking for. So remember, when we have problems like this, the whole is the original and the quantity is the final. The original is $400. The quantity is our unknown. And then we're decreasing the price. If we're looking for the final price, that means that we are going to be using 100 minus 45%. Then tell me 55% of the price is remaining. All right. And finally, temperature outside is 60 degrees. And the temperature is increasing, and we want to know what the temperature will be. Not what just the changes, but what the temperature will be. So this is a problem where we are looking for the final amount, not just the change. Oops, times the whole. The whole is the original. Well, the current temperature is 60 degrees. It's going to increase. So what we don't know is the temperature here. And since it's the final and it's an increase, this is going to be 100 plus 20%, or 120%, which is 1.2 times 60. All right, that's going to be a lot of what we're practicing on today. It's going to be just a lot of practice of writing equations from various different types of problems. Today's AM Kipsters will be able to write Q equals percent times whole equations for percent problems. All right, so percent of a whole, we've really got two types of problems that we've been looking at. One where we're just finding the percent of the whole, and one where something is changing, or you're comparing how much more one is than the other. So just examples of the percent of a whole type problems. When we're talking about commission, that's the percentage of a sale that a salesperson gets. Problems that very directly ask you for the percent of something. Problems that ask you to find the discount, tax, or the tip. And that's very different than finding the new price. So we kind of see these two look like they're very common and they're very similar. Just because it says tax, tip, or discount doesn't mean that it is going to be this type of problem. If you're asked to find the new price or work with the new price, then you're going to be using this particular other side. Percent increase or percent decrease when using the change. So remember, we've seen different problems. In this particular case, this is when we talked about the Q of the change is equal to the percent of the change times the final, or times the whole. So remember, when we're seeing those, is like the difference there is, are you given the percent of just the change, or are you looking with the quantity of the change versus the quantity of the final amount and the final price? All right, so in these particular problems, this is for commission. It's the amount of sales and the percent of are usually the key changers. Now, if you're using a percent increase or decrease or change, the whole is still going to be just like in the other side, the original. All right, percentage. The percent represents the percentage of the quantity. All right, and it matches. Remember what I say about matches? I mean, matches quantity, okay? So if we're talking about boys and girls, the percentage is going to tell you boys, and the quantity is going to tell you boys. So kind of as an example, quantity of boys, you better be talking about the percentage of boys. If you're talking about the quantity of girls, then your percentage better be the quantity of, or the percentage of girls. Examples like that. And finally, the quantity matches the percentage. So again, we see the same idea here, that these two should match. Sometimes we think it is the part. Tax, it's the amount of the tax, tip, or discount, not the final price. I'm going to throw one more word in there, profit. That's on markup problems. And in parentheses here, let's add this is not final amount. Because if we're talking about final amount, we're going to flip over to this other side where something is changing or we're comparing the values. So for the price is changing, and we're asked to find the new price, percent increase or percent decrease using the final amount. So again, this is kind of thinking about, we've seen this before. This is when I'm talking about the quantity of the final amount is equal to the percent of the final times the whole, and percent more / percent less. So these are going to be saying somebody has blank percent more or blank percent less. When we see these, in the whole category, the whole is always going to be the original value, or if it's a percent more, percent less than, whatever goes in that blank. Blank percent more than Johnny, well, whatever Johnny is going to be the whole. For the quantity, it represents the percentage of the whole that is left after the change, in a lot of, which if we're thinking about this, we're really thinking about like, well, if there's 10% of an increase, that means 110% is what remains. Or if we're taking off 10%, it's 90% that remains. And so kind of more mathematically speaking, if it's an increase, it's the percentage of increase plus 1, or 100%. So again, that's thinking about if the percentage of increase is 10%, same thing here. So the same thing, 1 minus the percentage of decrease, that's thinking about that as a decimal. If you want to think about it as percentage, it's 100% minus the percent of decrease. So again, just those examples, 10% increase, that's 110%, or 1.1. Percentage decrease, if it's a 10% decrease, that's 1 minus 1 minus 0.1, or 100% minus 10%. In these problems, the quantity is the amount of change. The final amount, or the person or thing that is being percent more or less, we're actually going to talk about the amount of change actually being over here. So that's in a slightly different spot. So make sure that you've got that noted. The person or thing that is more than, so blank percent, maybe it's Julie is 10% more than Johnny. Well, more than Johnny, Johnny makes that the whole, and Julie would be the quantity. All right. So for the rest of the period, realistically, you've just got a ton of these problems to work through. And really all you're being asked to do is to set up the equation. So all I want you to do for each of these is set up the equation. So I want you to set up each equation, and then I'm just going to run through. The rest of this video is just going to be me explaining. I'm going to write down all the answers and then go through and explain them all. If you got one right and you don't need to hear the explanation, you can skip forward past that part of it. But again, you should be working and completing each one of these problems before the answer is on the problem. Okay, now I'm going to quickly slide through each of the answers. I've put a lot of hints in terms of my underlines as to why the answers are the way they are, but if you are still confused about something, please feel free to mark it and raise your hand, or mark it if I'm not busy right now. Mark it so you can come back and ask that question later. So I'm just going to slide through these. Again, make sure that you've done each problem before the answer appears. So you'll notice with this last one that I've done it two different ways. One is to find the discount rate. Thinking about just the amount of change, one would give me the percentage of the final. What we should know is that if we get the percentage of the final, that means we have to subtract 1 from it to make sure, or the percentage from 1 to get the actual discount. Alright, I'm just going to scroll through these as well. Again, make sure that you've got each problem done before the answer is scrolled to. Again, there are hints in there a lot of times. If you still have questions, mark it until the appropriate time for me to be able to come by and check in. All right, go ahead and move on to your alone time.